So the question we are looking at is 62 of LEETCODE, and it's a question of DP basically, but I'm trying to do this by recursion. Of course, in the end it will show TLE, but for recursion concept clearing, it's a good question. It's a question of like kind of chessboard ones. A robot is located on a chessboard kind of things, which is of M n grid. You can also say grid, and this wants to reach the finish line, which is M into n. So we need to tell the number of unique ways it can reach here. Like one way is it can go there, this way, and there are so many ways. But the thing is, it can like only take two steps, which is either it can move down or either it can move right single at a point. Like it cannot jump directly here, it cannot jump directly here. If it needs to come here first, it will go down, then it will come right. Like single step it can take, no cross steps are possible. So the intuition here is uh, we have a chessboard, for example. We have a chessboard of 4 by 4. Uh, my drawing is so bad. Of 4 by 4, yes, a 4 by 4 grid, and which you can say m comma n equals to 4 comma 1 2 3 4. This is 1 2 3 4. So we are standing at this position and we need to reach this position. So this is our destination and this is our source, obviously. Now we have so many ways to reach here. Like for example, we'll discuss first. We'll start moving, and in how many ways can we reach to this box? Like we cannot come from up, we cannot come from down because we are standing here. uh, we are standing here, we cannot come from up, we cannot come from down. The only way possible is from left. So uh, there is one way we can reach here. Similarly here also, we are standing here, we cannot come from anywhere, like go back or come from top. The only way which we have is from left to right, also one way. Similarly one way. Now let's check for this column. If we are standing here and we need to come here, the only way which we can come is from the upside down. So similarly, one. The only way which you can reach the like zero at the first row and first column is one way, which is from either from sorry, either from top or either from left. Now things get interesting here. If you need to come in this, at this location, so there are two ways. Either you can come this way and this way. So there are two ways. Now you want to reach this location. You can obviously see there are three ways. First way is either use this path or use this path or use this path. I think all the paths are covered. So there are three ways. Now for reaching there, I'll just change my, just a second. Yeah. For reaching here, the heck, I changed it to worst color I can pick. Yeah. And you need to reach here. So you have this way, the direct one, then you can reach this way or this way, or you can reach directly this way. So there are total four ways you can reach. Uh, there is a one like common concept you can see, that it's always the sum of upper and the left one. So it's 2, this thing is 3, this thing is 4. Similarly, there are three ways to reach here. You can check yourself that there are only three ways to reach here, like directly this way and come this like this way and then the this way. So yeah, and there are three ways. Now let's check for this thing. There are six ways to reach here. This 10 ways, obviously four ways to reach here, and 6 plus 4 10 ways. This 20 ways. So if you want to reach here, there are total 20 ways. Now the uh, intuition is if you want to find a particular, like for example we are given just find out m cross n is 4 1 4 comma 4, but I need to find in how many ways I can reach 2 comma 3. So 2 is this, 3 is this, so there are three ways. How would I find the total number of above ways and total number of left ways, sum of them? So the basic intuition is if your function goes like I comma j, so what you need to do, I minus 1 j plus I j minus 1. You can easily understand this, like if this is I and this thing is j, so if I is equals to 4 here, this thing is I equals to 3, which is I minus 1, and j is same. This thing is j minus 1 and I is same for this thing 3. So this is the basic intuition for our recursive approach. We'll decide a base case. Base case would be if the like if you are standing on 1 comma 1, this thing is 1 comma 1. So how many ways are there that you can stand on 1 comma 1? Obviously there is single way. There's no other way you can stand, like obviously that's so obvious. So there's single way, and this will be our base case. Another base case would be like I and j cannot be negative. Like you cannot come from upward, or you cannot come from like outside of the board. You cannot just directly jump into the board. You must be present into the board. So one base case would be this should not be equals to 1, or this should not be I comma j should not be less than equals to, so it should not be less than 0. So let's code it. uh, I guess first we need to just let's declare there's a like function, this grid, and I've just returned it because this can be done directly. And now let's declare the function int grid here. Let's pass m and let's pass n. Then what we need to do, we need to decide the base case obviously and recursive case. So base case would be if uh, m equals to 1 and n equals to 1, which means we are standing on the first, the first thing, the first first matrix. So we would return 1 because there is only one way you can stand there. Another one is if m is less than 0, and obviously n is also less than 0. If like any one of them is, this is OR operator, if any one of them is equals to 0, then you just need to return 0, because obviously that's invalid. And in recursive case, we can just use our iteration of minus 1 thing, like grid and I minus 1 thing. So m minus 1 comma n, and you need to add the second, like upper and the left one, which is n minus 1 comma no, sorry, this is m n minus 1. I guess this should run correct. Let's see. Yeah, so I just what was the cases? These were 3 and 7. So let's see how this thing works. 28, yeah. But the thing with recursion is in problems like this, we generally use DP. And if you'll submit this, obviously this will show the TLE because of out of bound shit. But it works till a like quite extent because constraints are given here, and you need to use DP. But it's a like kind of good problem to clear your recursive approach, like how the recursion works and all. Thanks.